Purge-Gate is a backprop-free test-time adaptation method for point clouds. The core idea is simple: at inference, identify tokens most distorted by the target domain, and remove them before they enter self-attention. By adapting the token set instead of the weights, we get robust gains with no gradients, no buffers, no source data at test time, and overhead close to plain inference. Why this matters: 3D corruptions are highly non-uniform. Density drops, background clutter, lidar sparsity, rotations, and sensor noise rarely affect the whole object evenly. If we feed all tokens to attention, corrupted tokens dilute informative ones and flatten the attention map. Heavy TTA fights this with online optimization or episodic storage, which is brittle and slow. We take a different route: reduce input set noise rather than modify parameters. Under shift, layer norm stabilizes magnitudes but token directions become unstable. Query: key dot products drift towards zero, softmax turns nearly uniform, and heads lose selectivity. If we remove the most divergent tokens, attention regains contrast and the remaining structure aggregates more reliably. That is the bet behind Purge-Gate. For each input, compute a divergence score per token relative to a prototype G, rank tokens, and purge the top LPG. We provide two practical prototypes. PGSP uses source statistics to define G and measures, for example, Mahalanobis or cosine divergence. PGSF is source-free. It derives G from the model's own CLS direction and scores tokens by cosine similarity. Both variants are forward-only, no gradients and no cross-batch state. To keep the method gradient-free yet adaptive, we select LPG via a tiny sweep over a fixed set such as 0, 2, 4, 8, 16, 32, and choose the candidate with the lowest prediction entropy. This adds only a handful of short forwards. Because we skip adaptation passes, we also reset batch norm per batch so layers rely on current inputs rather than stale training moments. Evaluation spans ModelNet 40C, ShapeNet-C, and ScanObject NNC across 15 corruptions, using LN transformer classifiers. We also include Point Mamba to test portability beyond standard attention. The protocol is strictly source-free, single-pass, and stateless. Both PGSB and PGSF deliver consistent, sizable gains over source-only and match or surpass strong TTA baselines while avoiding gradients and memory. On ShapeNet-C, where many methods regress, Purge-Gate is among the few that improve over source-only. Efficiency is a major advantage. Latency remains near plain inference and memory is far lower than gradient-based TTA. Ablations show 3 points. First, resetting BN helps all methods, yet PG still leads. Second, the entropy-guided choice of LPG closely tracks a dense search and avoids over-purging. Third, performance is stable even with small batches where optimization-based TTA struggles. The same purge mechanism boosts Point Mamba, indicating PG acts at the token set level, not a specific attention block. On real-world ScanObject NN variants, starting from object-only weights, Purge-Gate still yields tangible improvements, underscoring practical value. Limitations are straightforward. LPG is a test-time knob, and with extremely tiny batches or extreme sparsity the gains can diminish. PG targets classification. Dense tasks like segmentation may need task-aware extensions. Domain shift corrupts a subset of tokens. Remove them. By purging the worst offenders before attention, we recover focus, improve robustness, and keep deployment simple: no gradients, no state, near-inference cost. Thanks for watching. If you'd like to try Purge-Gate, the code, pre-trained configs, and reproducible scripts are on our GitHub. For full results, ablations, and theory, please read the paper. We welcome questions, issues, and pull requests. Your feedback will help shape the next steps.